All right, so we're going to be looking at another mixed circuit. The only difference is here, besides being worried about the current and the electric potential, we're also going to think about resistance. So we're given the resistance values for some of the resistors there, and we're going to be using Ohm's law, which I've written on top of the chart, just as a reminder, in order to help us with this circuit. So again, we want to take a look at where the current goes. So we can see it comes out of the battery, through R1, gets to this junction, and has to split two ways. Since the battery and R1 are connected in series, we know they're going to have the same current. So that makes it easy to find the current through R1. The other thing that you can see I've done in the table, since we already have the current and the electric potential for the battery, we can use Ohm's law. So I've done that and solved for the battery resistance, which is 20 ohms. Anytime you have two values in a row, you can always use Ohm's law to find the third. So that can be very helpful. So here you can see we've got our 20 ohm resistance through the battery. And since the R1 is in series with the battery, we know it has to have a current of 0.3 amps. Now, I've got 0.3 amps and 8 ohms, so I can use Ohm's law to find the electric potential at R1. So I'm just doing V as IR, and I end up with 2.4 volts through R1. Now remember, just like last time, to find voltage, we need to look at a path. So I've drawn a green path here. We pick up 6 volts at the battery. We have to drop a total of 6 volts as we go around our path. So we've dropping 2.4 volts here. We can find out how many volts we drop at R2. So here you can see I've done the subtraction. 6 minus 2.4 gives me 3.6 volts at R2. So that's the first thing I figured out. Then I had the V, I had the R, so I'm going to use Ohm's law to find the I. So that's what I've done in pink right here. And you can see the current through R2 comes out to 0.18 amps. I've just drawn that over here so we can take a look again at that junction. 0.3 amps is coming into the junction. 0.18 is going down this branch. So we can figure out now how much is left to go this way. That will be the amount of current that goes through R3. So here you can see I've said that 0.3 amps comes in, 0.18 goes down through R2. That leaves me with 0.12 to come through R3. Now R3 and R4 are joined in series, so that means the current through them must be the same. So that 0.12 amps comes through R3 and then continues down through R4. So it's very easy to fill in the current for R4. It's just the same as the current for R3. So I've got those filled in there. Now, the only thing that's missing are the voltages in R3 and R4. And if you take a look at the chart, again, you can see that in the R3 row, I have two values, my I and my R. So I can use Ohm's law to find the V. And in R4, I have, again, my I and my R. I can use Ohm's law to find the V. So I've done that here, and I found out that there's 0.6 volts through R3 and 3 volts through R4. Another way you can check this is if you look at this branch and this branch of the circuit, they are in parallel. And we know when things are in parallel, the voltages or electric potentials must be the same. Since there's 3.6 volts here, that means there has to be a total of 3.6 volts here. So if I add the voltage for R3 and R4, that's 3 plus 6, which is 3.6, and there's 3.6 here in R2, so they're equal. So that's a second way that you can check that.